So section 3.4, the LU factorization. So let's see this definition and theorem. So let A be a square matrix. The one on the board is a square matrix. 2 times 2, 3 times 3, 4 times 4. That's the only thing. This is important. It has to be a square matrix. So you can find the LU factorization. A factorization of A, which is LU, where L is a lower triangle matrix and U is an upper triangle matrix. That's mean any matrix A, any square matrix, we can factor this matrix to 2 matrices. One lower triangle matrix and the other one is upper triangle matrix. When I multiply these 2 matrices, it's going to be the matrix A. Okay? We're going to see the steps when we do the example, how we're going to find the lower triangle matrix, which is the L, and how we're going to find the upper triangle matrix. The theorem says, if A is a square matrix that can be reduced to row echelon form. So you're going to get the square matrix, you're going to reduce this matrix to row echelon form using any row without using. So you're not going to change the rows. If you're not changing the rows and reduce the matrix, then the matrix A has an LU factorization. The only difference between this one, LU factorization, and P transpose LU factorization, LU factorization, you're going to do the same process, lower triangle matrix, upper triangle matrix. But when you change the rows, this one, you're going to get permutation matrix, which is only when you interchange the rows. That's, we're going to check how we're going to find the permutation matrix. Then you're going to take the transpose. That means you're going to get A equal P transpose LU factorization. It's going to be easier when we start doing examples. I'm going to show you how we're going to find the lower triangle matrix, upper triangle matrix. We've got 2 examples, then be enough. For 3 examples, we're going to do 4 times 4 also. Start with this example. It's LU factorization. Keep in your mind, L is the lower triangle matrix and U is an upper triangle matrix. So I'm going to start with this matrix. The first step to find the LU factorization is to reduce the matrix by using row echelon form. So the first thing I'm going to find U, the upper triangle matrix. Okay, that's mean upper triangle matrix. So here is the diagonal. So here is the diagonal. Upper triangle matrix. Okay, that's mean I'm going to keep these numbers here. I need to convert these 3 numbers to zeros because it's an upper triangle matrix. That's mean under the diagonal is going to be zeros. So my goal is to convert this one to 0, this one to 0, and this one to 0.
So we'll be converting it to 0 without changing the
rows.
Okay.
Yeah, that's important. That's a good question. Without changing the rows. Okay. So the first thing you're going to find is the U matrix, the upper triangle matrix. My goal is to convert this number to 0. So what's the step I'm going to do? If you just multiply this one by 1 and add it to this one, it's going to be 0. So what I'm going to say, I'm going to say R2, I'm going to multiply by 1 times R1 and add it to the R2. I'm writing down these numbers on purpose, you will see. So the new matrix is going to be, the first row is going to be the same, 2, 1, 1 negative, 2, and the third row, I'm gonna do also the steps. So 2, 1 times 2 plus -2 is going to be 0. 1 times 1 plus 3 is going to be 4. 1 times -2 is going to be -2. Plus -4 is going to be -6. That's my goal. Convert this number to 0. I'm not going to care about the rest of the numbers, okay? Next step, I need to convert the 4 to 0. So I'm going to multiply this row by -2 and add it to the 4. That means the new R3, -2 times 2, that means -2 times R1 plus R2. Again, I'm doing 2 steps on the same time. Okay?
So that should be R3, I believe.
R3, perfect.
And just to make sure that I caught what you said, when you did that first operation and you included the one R1, that was you said that was very intentional that you included the 1. Because
yes.
in my head, I was like, I'm just gonna do R1 plus R2. And then I heard you say, I'm doing 1 R1 and I'm leaving this 1 here on purpose. Is that right?
Yeah,
Okay.
yeah.
Okay,
I'm
just
going to
making
show
sure.
you why. Now, -2 times 2 is going to be -4, plus 4 is going to be 0. -2 times 1 is going to be -2. Minus 1, -3. -2 times -2 is going to be 2. Plus 0, 2. I'm done from the first 2 elements here. Convert these 2 elements to close. Okay.
-2 times -2.
We multiply by -2. -2 times -2 is going to be 4 plus 0 is going to be 4. So you have to be careful with numbers. Next element. We convert these 2 numbers to zeros. Now we just have to convert this number, which is now, check, it's -1, now became negative. That means I need to convert this one to 0. So I'm going to do the next step here. That's important. I'm going to convert -3 using the diagonal, using the 4. So what I'm going to do, instead of dividing the 4 by 4 to convert this number to 1, what I'm going to do, I'm going to say, I need to get a new R3, because that's my goal. If you divide this one by 4 and add it, it's going to be 1, right? So what I'm going to say, I'm going to multiply this row by 3/4. This row. So if I multiply this row by 3/4, this number is going to be here what? 3, 4 times 3/4. Cancel this, is that 3? And add it to the R3. So 4 times 3/4 is going to be 3. Added to the -3, the result is going to be 0. You got it? So instead of dividing, then you're going to go back and so just multiply 3/4 and add it to the -3, the result is going to be 0. And that's my goal.
Professor, could you also start with row 2? So my thought was to take row 2 and add row 3 to get a new row 2. So you would have had, your new row 2 would have ended up like 1, -2, it looks like. Could that have also been the route that you take, or was it necessary to go the route that you went?
Because my goal is to convert this number, right? So instead of doing 2 steps on the same time, like instead of convert the 4 to 1, you have to divide by 4 and divide this one by 4. Then you're going to do another step by converting this number to 0. So what I'm going to do, I'm going to say, okay, if I multiply this one by the reciprocal, but with the 3, 4 is gonna cancel with the 4. The left is a 3. Added to -3 is going to be 0. Always, when you converting the numbers to zeros, use the diagonal row. Like you say, okay, I can use the 1. Yes, you're right, you can use the 1, but I'm going to use the diagonal row always. Okay, so my main row to convert the matrix to upper triangle matrix is to use the diagonal row, okay?
It will be like a three independent sections.
3 independent, yes. That's why we need to find the solution X, Y, Z.
Oh.
Okay? The identity matrix 1, 1, 1, the diagonal row. You got it, Charlie? So let's keep going. This is 2, 0, 0, 1, -1, and so 1, -2. Then keep this one 4, -6. Then if you multiply by 3/4 and add it to this one, it's going to be 0. Now, if I multiply -6 by 3/4 and add it to the 4, this is going to be 3. And this one is going to be 2. It will be -9/2. That's 4. Okay, we need to add this together. So 4/1 and be times 2 will be -9/2. Add to the 8/2. Going to be negative. That means this number is going to be -half. So is the new matrix is upper the triangle matrix? The new matrix is upper triangle matrix.
No, sorry, yeah, you're good, never mind.
No, go ahead.
No, I thought I said something, but it's all good, sorry.
So this one is the U matrix. The U matrix is upper triangle matrix. That's our goal. We convert these 3 numbers zeros. So we got it from the first one. Now we need to figure out how we're gonna write down the lower triangle matrix. So let's write down the U. Sorry, the L. So the L matrix first of all, I'm gonna write down the identity matrix. It's lower triangle matrix. So 1, 0, 0, 1, 0, and 1. Is that lower triangle matrix? It's the identity matrix, but I'm not gonna write down the zeros here. Because when I multiply this one by the upper, you see here is not zeros, here is zeros. So it's like the opposite matrix. I put 1, 1, 1 is the identity matrix without these 3 elements. This number, this operation here, we convert this number, right? We multiply by 1. So what I'm going to write down here, the opposite one. Remember the E matrix? We wrote the opposite of the number. So 1, -1. The second operation, which is this element. -2, you're gonna write down 2. The third operation, 3/4 to compare this number. So here, the 3/4, we're gonna write down -3/4. That's it. This is the L matrix. If you multiply, if you say A equal LU, if you multiply this matrix by the U matrix, the result 100% is going to be a matrix A. Okay. Go ahead, check that. Multiply LU. And again, it's really important to practice, even if it's the same example, practice by doing the steps. Find the LU Factorization. So the first thing with this matrix, my goal is to convert these three numbers to zeros. Gonna start with the 9. I'm gonna say R2. That's mean I'm gonna multiply R1 by -3 and add it to R2. So I'm gonna say -3 R1 plus R2. So the new matrix is going to be, the first row is the same. The second row, this one is going to be 0. -3 times 3 is going to be -9. Plus 5 is going to be -4. -3 times -1 is going to be 3. Plus 4 is going to be 7. We're done from this row. For the third row, I need to convert the 3 to 0. So what I'm going to do, I'm going to say R3 is going to be multiply this one by -1 and add it to the R3. Now, -1 times 3 is -3, plus 3 is going to be 0. -1 times 3, -3 plus 4 is going to be 1. Times it -3, -1. -1 times -1 is going to be 1 plus 21. So 1 plus 21 over 4. That's mean 4 over 4 plus 21 over 4, and the result 25 over. That means here now we have 25 over. Yes or no? Next step, which number we have to convert? We need to convert the 1. So I'm going to do exactly like what we did before. Now I have -4. What I'm going to do, I'm going to say R3. By the reciprocal, if I multiply -4 by 1 over 4, it's going to be 1. -1 with negative sign. A plus 1 is going to be 0. So what I'm going to say here, I multiply by 1 over 4 by R2. 1 over 4 times -4 is going to be -1. Added to the R3 is going to be 0. That's 3, -1, and 0, -4, and 7. And this one is going to be 0. This one is going to be 0. The third one, gonna multiply by 7 times 1, 4. It's going to be 7 over 4. And you're gonna add 25 over 4. It's going to be 32. Divide by 4. It's going to be 8. So this one is the U matrix. Okay? Can we write down the L? You see, when I'm writing down the L, lower triangle matrix. And what I'm going to do, 1, 0, 0, 1, 0, and 1. The first number, -3. What I'm going to write down here, 3. The second number here, -1. What I'm going to write down here, 1. The third operation, 1, 4. What I'm going to write down here, -1, 4. That's it. Check. And A equal LU. Now we have 4 times 4 matrix. The first thing, I remember that 2 years ago, like you give the student not square matrix, and they ask them find the LU factorization. And they try to do it hard, but you can't, because the main thing it says if A is a square matrix. So that's all you have to check. It's a square matrix. 1, 2, 3, 4. 1, 2, 3, 4. It's a square matrix. 4 times 4. That means I can do the LU factorization. Okay,
Professor, so square matrix is just like both the rows and columns being the same number?
the same number, yes. So is this one a square matrix?
Yes.
Yes. So let's start finding the LU factorization. Be careful here. Here's the diagonal. That's mean. I need to compare this one. You see how many elements? I have to convert all these to zeros. Okay, so let's start. I'm gonna do the 3 operation at the first one at the same time. I'm gonna do 3 operations at the same time. So the first thing I need to convert -2 to 0. That means R2 is going to be multiply this one by 2. That means 2R1 and add it to the R2. Yes, good. So 2, the first row is going to be the same, which is 1, 4, 3, and 0. Let's take the second row. 2 times 1 plus -2 is going to be 0. 2 times 4 is going to be 8. Minus 5 is going to be 3. 2 times 3 is going to be 6. Minus 1, 5. 2 times 0 plus 2 is going to be 2. Okay, I'm done from row 2. The second one, I need to convert the 3 to 0. So I'm going to say R3 multiply R1 by -3 and add it to the R2. Okay, so -3 times 1 -3 plus a 3 is going to be 0. -3 times 4 -12 plus 6 -6. -3 times 3 -9 minus 3 -12. Yes or no? 0 -4. Was -3 times 0 0 minus 4
Should have been -3 R1 plus
R3. Yes. Next one, we're going to convert -5. So I'm going to say R4 is going to be 5 times R1 plus R4. 5 times plus. So 5 times 1 plus -5 is going to be 0. 5 times 4, 20. Minus 8, 12. 5 times 3, 15. Add 9, 24. 5 times 0 plus 9 is going to be 9. You got it? This is the first, you see? 3 of 5, convert the number to 0. Now, next step, I need to convert 6, 12. What else? Here is the diagonal and 24. Who has a question so far?
That way out of habit. Is that a valid way of doing it, or is that going to?
No.
Okay.
You can do it.
Okay,
But I prefer this one because it's okay, you can do it. It's fine. But you have to get the same result.
gotcha. Okay,
It's fine, you can do it. This is still math. Now, our goal is to convert -6 and 12. So I'm gonna use the 3. 3 times 2 is going to be 6. That's easy one. So I'm gonna say R3 is going to be 2 times R2, and you're gonna add R3. Because 2 times 3 is going to be 6. Add -6 is going to be 0. Here is my new matrix, which is 1, 4, 3, 0. And here is going to be 0, 3, 5, 2. Zeros here. So 2 times 3 is going to be 6, minus 6 is going to be 0. 2 times 5 is going to be 10, minus 2, -2. 2 times 2 is going to be 4, minus 4, 0. I'm not gonna care about the 0. I got 0 here, it's okay, it's fine. My goal is the lower triangle matrix. It's supposed to be 0. That means it's an upper triangle matrix. So next step, I need to convert the 12, 3. So R4, I'm going to multiply by -4. That's mean -4 times R2, and you're going to add R4. -4 times 3, -12, plus 12, 0. -4 times 5 is going to be -20, plus 24, -4. Is that right? No, it's 4. Because -4 times 5 is -20, plus 24 is going to be 4. And -4 times 0 plus 9 is going to be 9. Did we finish?
Isn't it -4 times?
Oh, we're using R2. -4 times 2. Let's go. -4 times 2 is going to be -8. So it's going to be 1. Yeah. One more step. Let's do it here. The last step to convert this number to. How are we going to convert this number to 0? I'm going to use diagonal -2. So I'm going to say R4 is going to be 2 times R3 and add R4. That's easy. You're going to get 1, 4, 3, 0, 0, 3, 5, 2. Here's 0, -2. 0 here. There's 0, 2 zeros. This one's going to be 0. And here, 2 times 3, which is 0, also going to be 0, plus 1 is going to be 1. So this is the U matrix. Okay. So write down the L matrix. 1, 0. And here's 1, 2 zeros. Here's 1, 0, and here's 1. Now let's check. Where is the first operation? 2, what I'm going to put here? -3, 5. Done from the 3 operation. Here, 2 and -4. What I'm going to add down here, and here, 4. The last one, which which is here. Here is the operation 2. What are we gonna write down here? So we have L, we have U. So I check A equals L times U multiply.
You can let us do more times.
Check here. They're gonna ask you find the factorization. They're gonna tell you it's LU factorization or P transpose LU factorization. So the LU factorization, you're gonna do the LU factorization. Oh, sorry, I didn't change to the next one. Talking about this example. Again, they're not gonna tell you it's LU factorization or P transpose LU factorization. Find the factorization. It's a square matrix, so I can find the factorization. What's the difference between LU factorization and the P transpose LU factorization? What's the difference between this one and P transpose LU? Yes, if you change the rows for any matrix, it's going to be this one. If you're not changing the rows, it's going to be LU factorization. So now, I'm going to look. Can I convert this one and this one and this one to zeros? Can I convert -1 to 0 by using the 0? You can't. But any number you're going to multiply by 0 and add it to the -1 is not going to change to 0. What does that mean? That means this is not LU factorization. I have to interchange the rows. I'm going to switch 1 with the 3. So the first step I'm going to do, I'm going to change R1 with R3. So it's going to be 1, 2, and 2. -1, 4, 1. And here 0, 1, 3. So when you change the rows, that means this is not LU factorization anymore. It's with the P transpose. That means you're gonna find the L, you're gonna find the U exactly the same way we did on the previous examples, but there is another matrix which is this one. This is the P matrix. When you interchange the row, it's the P matrix, okay? If you swap the rows more than one time, that's when you have 2 P matrix, P1 and P2, you have to multiply these together, okay? So now, on this case here, we're gonna do exactly the same process to find the U matrix. I already have 0 here, so I just need to change this one and this one. That's me, change this one, I'm gonna say R2, it's going to be 1 times R1, and add it to the R2. This case is going to be 1, 2, and 2. This one is going to be 0. 1 times 2 plus 4 is going to be 6. 1 times here is going to be 3. And this one is also 0, 1. We got it from this one. We're gonna keep going. Now our goal is to convert the 1. So we're gonna say, so how are we gonna convert the 1 to 0? That means R3 is going to be, which number you have to multiply by 6? When you add it to the 1, it's going to be 0.
Supposed to be 5. 1. Oh,
Talk about this one.
never mind. 6. Is it 2 plus 4 or 1 plus 4?
Why it's 1? Because 1 times R1, 1 times 2 is 2. Plus 4, 2 plus 4 is going to be 6. Okay, you got it? So now, which number are going to multiply the 6? You're going to multiply by -1/6. Because 6 times -1/6. You're gonna cancel these. What's the left? -1. When you add it to the 1, it's going to be 0. So I'm gonna say -1/6 times R2, and you're gonna add to the R3. So maybe 1, 2, and 2, 0, 6, 3, and here is 0, 0. Now, -1/6 times 3. Cancel this is going to be -half. -half plus 3. That's me times 2 and 2. It'll be -half plus 6/2, and then it's going to be 5/. Which matrix this one? This one, the U matrix. Now let's find the L. Be careful. I'm not gonna include this one in the L. The L, only the operation we did. 1, 2, 2 operations we did. So 1, 0, 0, 0, here's 1. One, 0, and 1. The first operation, which number here? It's a 1, so I'm gonna write down here -1. The second one is -1/6, which is here. So what I'm gonna write down here, 1/6. What I'm gonna write down here.
Will be 0.
Gonna add 0. It's already 0 here, so I'm just gonna put 0. Okay, so we have L, we have U. We need one more matrix. One more matrix, because if you multiply L times U, it's not gonna be the A matrix, because we still have to do one more operation, which is the P matrix. Now the P matrix, how are we gonna get the P matrix? The first thing, the identity matrix, it's 1, 0, 0, 0, 0. This is the identity matrix, right? Now I need to write down the P matrix. That's mean P matrix is going to be the operation I did as well. Change R1 with R3. I'm going to go back to the identity matrix, change this all with this one. So it's going to be 0, 0, 1, 0, 1, 0, and 1, 0, 0. This is the P matrix. I need to find now what? The P transpose. Because it's P transpose, check here, A equal what? Was A equal P transpose LU. I have the P. The transpose, P transpose equal what? The first row is going to be the first column. The second row is going to be the second column. The third row is going to be the third column. But in this case, with this example, we're going to get the same one. This is one here. If you do the transpose, it's going to be the same matrix. See the first row, the first column. The second one, the second column. The third one is going to be the third column. Now, to find the A, you have to write down B transpose there, then L, then U, when you multiply it, it's going to be the A matrix. Okay, go ahead, check that.